So if you're presenting your things, could you please design the software design, the electrical design, and whether or not it's sailed or whether it is going to have a go at being sailed anyway. Is that alright?
Yeah. So we have USNA and first.
Okay. This is ended up naming the boat as a development from Moo. This is the Portable Electrical Engineering Platform. It also, for any of you who are familiar with Easter, they're the little yellow fuzzy peep candies, and this looks just like it. So the whole graphics are coming later. And this is and presented by the Naked Scientists. Okay, hull design. This is a Maximoot, the boat I designed almost a year ago, and they built this as hull number 1. So we took number two. So the hull shell was a basic polyester hull shell. We went out, got some lead ballast, 6 kilos of lead ballast, poured that in last night, encapsulated with epoxy, so we got the stability. We went out and got the plywood deck with stringer reinforcements in key locations. The mast deck was reinforced, and otherwise it's a. Oh, and then we had designed a rudder. This is not a section, but it is an airfoil section. It's plywood over a carbon fiber tube. We got a yoke going into the servo. The rig design is we do somewhat plug and play. That's the C-scope basic rig. And what we've done is to increase because there's more stability in the boat, to strengthen the rig. We've got a little bit stronger shrouds, and we're in the process of building some spreaders that will go on there in a second. We firmly believe that you should be able to do it well. About an hour after the presentation is our expectation.
So part of the peep show, we're going to open the boat up and see what's inside. So we have a full controls package that movable, so we can work on it. It focuses on the Rabbit microprocessor. We're taking an analog to digital voltage measurement for the wind sensor. The GPS in course over ground. Because of all the metal in the small area, we said the compass was just not going to work. Integrated are the pulse width modulated signal, the rudder, and then what will be for the sail servo. Servo will fit through the deck, so it will be watertight. We have these through fittings, which are watertight, gasket sealed on the bottom, that the wires will go through and then connect into this. Kind of quick connects. Software, yes, the software. So the software is written for this, should plug and play in. We did that last night. Again, the analog to digital converter will sail upwind according to apparent wind angle, and then downwind to the compass. So that minute error in the course over ground will still be able to sail upwind. Course over ground will not let us sail upwind, so that will be our fix for that. There's also we'll have the full navigation complement to be able to sail to multiple marks and come back.
It's fine.
Yeah, there's no wrong answer. I'm just interested.
New and recycled.
So none of this
cover is new.
Well, okay.
The plywood was new.
Sure.
That you rig is essentially recycled.
What I meant was in terms of thinking.
So, so we brought none of this here.
Yeah.
It was just spares. We had no intent to build this. We found someone with a rig. We found someone with a hull. That's not our hull. Even though pole design is not ours. We stole some guy's plywood in the back of his pickup truck. And you know that's not true because there's no pickup trucks. And these are all spares integrated between us and C-scope. So.
But is there anything on this that has never been done by you before? Either in code or in...
Well, the hull's never been tested.
The rig's never been used. The
rigs.
Okay.
I've actually never steered by cog either, so...
What is the wind sensor actually?
It's a
potentiometer. It's actually a two-phase potentiometer, so it doesn't have dead zones. But
It's linear?
Yep.
But for simplicity, we're just using a single phase and pointing the dead zone out.
A to B.
So essentially, we started yesterday at noon thinking about this.
So this is 24 hours. Okay, yeah. It's controlled by an Arduino, basic GPS, and a Honeywell compass, AS450 for the sensor. The sensors work, it's pretty much out yet. We'll try synchronously and navigate multiple waypoints, but never got that far.
Anyone else?
Someone else they've left,
Oh, okay, okay.
but never really finished it up and
So
in.
is that about
Denmark.
Denmark?
Anything else?
So we can sail, hull, software, electronics.
The hulls in Mayport, obviously. Sails a wing sail.
Where did you get the sail?
Sorry?
Where did you get the sail?
DSL.
Fair enough, lying down.
So what's new and different and never been done before?
Well, the hull's tried and tested. The rig is tried and tested. What's new is software, I guess.
And how does it differ from software you might have developed in the past for your other boats?
Doesn't really.
It doesn't really, but it was written from scratch.
Yes.
We've
This
never done an
morning.
Arduino move.
No.
And the
It's
Right.
always been kit based.
Okay.
This is your first time?
Yeah. Well,
Yeah.
first. Stuff like that, yeah.
Okay. Has it sailed?
No.
Is it going to? You got a tent?
Maybe today, probably not.
Give it a go. Go on.
I think it's basic working. We can always pull it out.
It'll be a change.
Right.
I can present you, I think, the freshest boat of all because most of these parts are really new. They are from 2 days ago, I think.
No one believes it.
Guys went to a supermarket at 1 o'clock, I think, and bought a grill, bought some water bottles. We drank the water, so it's not complete anymore. We get some rudder from Moop because it's the deck. We didn't know that. Sorry. We got a used servo from Potky's team, an Arduino, but the electrical side they'll tell you it. A real sail with beans and flowers. That's really good. And we got a 3D printed wind sensor from the team from Liverpool. There's a magnetic compass inside. We got a special keel design that we already tested and we'll change it. So, it basically sails. It drifts a lot, so we try to fix that. We got a fixed main jib and cannot sail directly to the wind patch. Not directly, but we can only, I don't know the name. Beam Ridge, say Beam Ridge, but I heard that's okay.
That's all we have to do today.
Okay, so yeah, I think that's it about the construction.
The software?
The software is coming out.
No, actually not the software yet, the electronics part. As you can see, this is a pretty different boat from the other two. This is completely improvised. We have an Arduino running with a shield on it. I think the GPS is from Fast Track. And we had to power up the servo in some way because there is enough current for this. This is a pretty heavy rudder. So we had a battery support and sort of some wires into it just to improvise it. Unfortunately, there was a problem. As you can probably see, the magnetic field inside is not so smooth, so the compass isn't responding very well, and so our control system is basically winding up all over. But this is it. It's a pretty simple design, and now for the software, I'll explain something.
Yeah, so software. We're electrical engineers, we hate software. But oh, sorry, but it's stable, right? Okay. The software is just a typical layered architecture, you know, hardware layer, the steering, and then the skipper on top of that. We hard code the coordinates of the buoys because we didn't really want to or have the time to go to serial communication or worse, wireless communication. So it's very simple. It just uses well, supposedly it will use the compass for heading control, simple PI controller, adjustable gains, etc. It's proven to work very well in our other boats. So we decided to try it again. But since the compass went haywire with all the wires around it, we thought about changing the algorithm to a wind direction based algorithm. Except we only thought of that an hour ago, and so that's not implemented. But yeah, that's basically it. conclusions to take from this is that Asda is a great place to buy stuff from at 1 in the morning. I wasn't paid for the advertisement. So, oh, there's an important feature. You can regulate the water level on the bottles. That's very important. Or sand level, as you wish. Yeah.
And you've sailed it a little bit out in the
Yes,
yeah?
it's still wet.
Still wet.
Yeah, it drifted.
Sailed.
Then it sailed, yes, but it was controlling. But yeah, the keel isn't really the best design for it.
Sure.
We just put two plywood the thing is together. It should probably be wider. But yeah, at least an extension of it should be something usable.
Why not just sink a straight keel back? Why did you?
We didn't want to add any weight in the center, because our purpose was to balance it on the side, on the bottom.
Right, yeah.
So we thought about just getting some drag in
Because
there.
it's a pretty heavy servo for this purpose.
Sure.
So we had to balance it with the batteries, and then if we someone had an idea, I think it was Alex, to use a hammer as a keel, but eventually we thought that might just be a little bit too much weight, so we went to the plywood.
Okay.
So is there more weight on the keel, or is that it?
No, there's no weight on the keel.
It's just that if you'd have introduced that weight on the keel, it would be too much for the whole boat.
Yes, exactly. Yeah.
This was done in basically like 8 to 9 hours, so we
Yes, we just thought yesterday, we woke up, let's build a boat. Why not? It's a competition, so.
Indeed.
Sure, so we did. Yes. Yeah.
Any other questions?